Let's first talk about properties of liquids, and then we can come back and talk about the properties of gases. So I can get rid of that and put this here for now. So we have this done. So I can do that. I can do this. So the main properties when I think about liquids are surface tension, adhesion, viscosity, evaporation. So what is surface tension? In a liquid, this is the scenario. There are molecules everywhere. Pretend that they're equal. And they are being attracted on all sides. There are forces that exist, right? And in order for this to stay a liquid, do they all have to be equal and opposite? Now what happens on the surface? There are 4 forces on every other molecule except for the ones that are on the surface. How many forces do these ones have? Well, look at this one. So look at number 1. How many forces? Well, how many on number 2? How many on number 3? How many on number 4? Now imagine if I do 5, 6, 7, 8. How many forces on number 7? And the sum of the forces in all of these cases should be 0 because they're being attracted on all sides, right? So that means 4 forces, the effect of the 4 forces should equal the effect of 3 forces. So which one will be bigger? The one on 3, right? That's the reason for surface tension. Make sense? So the same force divided over 4 versus the same force divided over 3. That will pull it down. The 3 of them will pull it down towards the surface. And that only exists at the surface. Make sense? So in fact, surface tension is not really a force. It is actually the surface force per unit length. Because it depends on the fact that the surface has only 3 forces pulling it down. So surface tension, and you're right, somebody said cohesion. Yes, they are cohesion forces, but where they arise from this fact. Make sense? Okay, so yes, now the formal definition is cohesion, also called stickiness, is the tendency of similar particles to be attracted to each other. In other words, you could also say at the surface, fewer neighboring particles implies higher energy, higher pull energy, right? Versus the same force divided over 4 sides, same force divided over 3 sides. So, and now, as always, there should be a formula. Oh, and then you could also write, I know this is not kosher, don't tell anyone. We'll just put it on YouTube. Surfaces want to shrink. Yeah, I know this is not the right thing, but think about it this way. They want to shrink onto themselves, right? They want to be pulled down. So the definition, as always, of surface tension is surface force per length along which the force acts, or force per unit length. It's the same thing when we talk about pressure. Pressure is not force, it's force per unit area. So keep that in mind, right? So this is the same thing. It's force per unit length. Newtons per meter. It is not newtons. Yes, sir.
So does the gamma have a specific name?
Yeah, it's called surface tension.
Oh, so surface tension.
Yeah, that is what. Yeah, we don't write ST.
Yeah.
We just write gamma instead. Okay, adhesion. What is adhesion? Well, what happens to the sides of these molecules? So I want to take the same picture and think about what will happen to its sides. What will these molecules do to the side? What are the two things they could do? Can attract or repel, right? So they can either attract the side or they can repel the side. When they attract towards the side, we call it adhesion. What will adhesion look like? We've all seen things do that, right? They like the container that they're placed in. And anyone remember what this was called? Very good.
Oh, wait, that's the name. That's the name.
So now the next question is, where should you measure from when you have a situation like this? The bottom. So you always measure the liquid from here. What could be the other opposite effect? So what does mercury do when you put it into a glass? It curves down, right? Because it doesn't like anything else. It likes itself way more than it likes the container. Wow. Yes.
Why do we measure from the bottom?
Because the actual level of the liquid is the bottom. So for example, if you had this container, it'll still have a little bit of extra at the top, but where is the actual liquid? Right? So the actual level is this one. Not this little one on the side. Does that make sense? So the standard is you always measure from the middle. Right? Okay, what is viscosity? Yes, thickness. And we will talk more about it later. So the more viscous something is, the less likely it is to flow. So the official definition of viscosity is the resistance of a liquid to flow. And things get more viscous the faster you want to move. No, like air. The faster you want to move, the more viscous they appear. They don't get viscous, they just appear to you to be more viscous, right? Because the drag increases as you try to go faster and faster and faster.
When you're in a pool and you like push off of the wall, and it feels like all the water.
Yes. So evaporation, what is evaporation? Good. How does it happen? Good. What does heat do? No, wait, I can't hear that many people. One at a time. So yes, it is a conversion of a liquid to a gas. How does it happen? What did we say that the surface molecules had a lot of? Energy. So how do you think we get to evaporation?
That way,
So somebody said we apply heat to it,
yes,
which means what does heat do?
the energy increases.
Heat gives it the
enough
energy.
to turn into yes.
So it gives it enough energy to overcome the surface tension, the attraction of energy at the surface. And once it has enough energy, it doesn't know what to do with it. It converts it into kinetic energy and it just flies away. It's like, "Poof, I'm going, bye." Okay, so evaporation is surface particles gain kinetic energy through addition of heat and then fly away. And then fly away. That's good enough explanation, right? Yeah. And when they get cold, as they inevitably do, they do what? What is opposite of evaporation?
Condensation.
There we go. And how does that happen? They give away all of their kinetic energy, they cool down as a result of it, and they're like, oh, we're too heavy now to fly.